Congratulations on making it to the end of section 3 of the Complete Android Developer course. You've covered a lot of stuff already in the course, as well as making your currency converter app in the previous section. In this section, we've looked in Java in a lot more detail, and we've covered variables, arrays, lists, maps, loops. We've created random numbers, as well as our little higher or lower app. And then we've looked at classes as well, and also if statements. So we're going to try and put as much of this together in this little app. And I've called this app Number Shapes. There are two types of numbers that generally have shapes, and they are triangular numbers and square numbers. And what we're going to do is create an app which allows the user to put in a number, and it will tell them whether it's a triangular number, a square number, both, or neither. Now, this may not be the most useful app in the world, but it will allow us to practice almost everything that we've covered, and also does require you to do a little bit of searching online as well to find a couple of new techniques that we haven't looked at yet. You may even need to look up what a square number is if it's been a while since you've worked with them. So that's it. If you're not really sure where to get started, then just follow along with my explanation, but otherwise, give it a go, best of luck, and remember to try and do it in an object-oriented way with classes if you possibly can. Best of luck. Alright, I hope you managed it. You may notice that I've actually settled in the browser rather than going over to Android Studio, and that's because I'm actually going to create the logic for the app in the browser and then move it over into Android Studio. And that's slightly more straightforward for me here because I can then run the logic several times without having to compile the app every time. So let's start afresh with a new Hello World program, get rid of that one line that we don't want, and then save as Number Shapes. So remember, our main aim here is to work out whether a particular number is a triangular number, a square number, neither, or both. So let's start off with a number class. You may notice now that I gave you a bit of a clue as to how we might set this out in the final example of the previous video. So here's our number class, which is going to have our number variable contained within it, and then our tests for is it a square number, is it a triangular number. So let's start by creating our variable number. And then I'll work first on whether it's a triangular number. So let's create a public method that returns a Boolean, and we'll call it is triangular. There we go. Now let's just remind ourselves, what is a triangular number? There we go. So it's the sequence 1, 3, 6, 10. So the difference goes up by 1 every time. So the way I'm going to test for a triangular number, and you can of course do this many different ways, is I'm going to have a counter variable x, so int x, which is initially 1, and just like we had when we displayed the first 10 triangular numbers a few videos ago, I'm going to have a triangular number integer as well, which will work my way up through the triangular numbers. And essentially what I'm going to do is keep generating triangular numbers until we get to the number. And either the number will be equal to a triangular number or it won't. If it is, then it is a triangular number. If it's not, then it's not. So we want to keep going as long as, so while our triangular number is less than our number that we're working with. And essentially we want to keep going up the triangular numbers as long as this is the case. So, how do we build triangular numbers? Well, what we did before was increment our counter variable, so x is now 2, and then take our triangular number and add x to it. So this will create a series of triangular numbers, and it will keep on going until either triangular number is greater than the number or triangular number is equal to our number. So once we're there, we can check to see if triangular number is equal to number. That means our number must be a triangular number because it's in the sequence of triangular numbers. So if that's the case, then we're going to return true. Whoops. If it's not, we're going to return false. And that's it. That's our method for testing whether our number is triangular or not. So, of course, we should definitely test that. So let's create our new number. I'll call it my number, which is a new number. Hopefully you're writing out this object-oriented code quite smoothly now, which is a big step forward because it's by no means easy to get to grips with. And then we'll set my number.number. Initially, let's set it to a triangular number. So say 6, for example. And then, because we're just testing, I'm going to just output the result to the logs, to the console, sorry. So my number dot is triangular, and then brackets, and with any luck then that will return true because 6 is indeed triangular. Let's take a look. Okay, looking good. Let's try it on a non-triangular number. False. Brilliant. Okay, just a couple more. 10 is triangular, so that's true. 20 isn't. False. Fabulous. Okay, so we've got our is triangular test up and running. Now we need to create an is square test. So I'm going to do that up here. So same as before, public, and we're returning a Boolean, and we'll call it is square. So already, hopefully you can see the sensibleness of keeping all this logic in one place. It just makes a lot of sense, and then when we're working down here, we don't really need to refer to the logic much at all. So a square number, let's just have a quick Google, is a square number. So a square number is the product of a number multiplied by itself. So 1 is a square number because it's 1 times 1. 4 is a square number because it's 2 times 2. 9 is a square number because it's 3 times 3, etc. So probably the best way to test whether a number is a square number or not is to find the square root of that number and see if it's a whole number. So the square root of 4 is 2, for example, because 2 times 2 is 4. The square root of 9 is 3 because 3 times 3 is 9, etc. So how do we find the square root of a number? Well, that's one thing we haven't covered yet. So I would expect you to search for something like Java. Oh, you can see I've already done it just to check that it's there. Java, there's a square root method. Perfect. That's exactly what we want. So it looks like the method that we want is math.squareroot x. So I'm just going to copy that and jump back over. Now, just to check that this works, I'm going to do a quick test. let's do the square root of my number dot number. There we go. Let's take a look. So that should give us the square root of 20. Okay, fair enough. Perfectly reasonable request. I've said this is going to return a Boolean and it doesn't. So let's just for now return true so that we can run our code. There we go. That looks like the square root of 20 to me. Brilliant. So that is exactly the function or method that we need. So let's copy it again up here. So let's create a double. I'll call it the square root, like that. And that's going to be math.squareroot. And here I just want to square root number. All right, hope you're still with me. The main thing I want to test about this is whether or not it's a whole number, because if it is, then we're dealing with a square number. If it's not, then we're not. That's another thing we haven't worked out how to do. So let's do a quick Google. Java test. Oh, again, you can see I've been there just to make sure that everything is available online. So how to test if a double is an integer. That's a perfect question for us. So yep, that's exactly what we want. Okay. So it looks like we use the math.floor method. So math.floor, if you don't want to read that, is a method that finds the integer below the number that we're looking at. So at the moment we've got, say, 4.47. So the integer below that is 4. So actually that makes a lot of sense. If the number that we're looking at is the same as the number when rounded down, then it must be an integer or a whole number. So that's what we want, I think. If we have a look at the other part, that tests whether it's infinite or not, which probably is not going to be relevant for us. So I'm just going to leave that bit out. But if you want to just copy that in, then it's not a major problem. Okay. So this is our test. So we want to test if, we don't want variable this time, we want square root is equal to math.floor of the square root then it is a square number, so return true. If that's not the case, return false. There we go. So just to recap, we've found the square root of our number, and then we've done a test to see whether that number is equal to that number when it's rounded down, which is just another way of saying, is that number a whole number, an integer? And if it is, then our original number must have been a square number. If not, then return false. Okay. So now let's use my number dot is square. And of course, we don't need anything in those parentheses anymore. So 20 is not a square number. So when we run this, it should give us false. Hurrah! Let's try a square number then. 9. 9 is a square number and it's giving us true. Fantastic. I think I'll just try a couple more. 50 is not a square number, so that's false. But 49 is a square number, and that's true. So that's pretty good. So now we've got a bunch of code that we can just copy straight into our app because it's so nicely set out. It doesn't involve any buttons or getting the value of text edit fields or anything like that. It's nice and clean as far as that's concerned, which means we can just use it straight away. And of course we could copy it into another app if we wanted to use this somewhere else as well. So that's one of the advantages of this nice clean class structure. So let's take this code and make our number shapes app. So over to Android Studio. Here we go. So we've still got our higher or lower app, or I have at least. So let's create a new project. We'll call this number shapes. And then all the usual default options. There we go. And here we are. So this bit of the app should be relatively straightforward for you now. It's very similar to what we've been doing in the previous two apps. We just need to set up our layout, have our button and our text field, and then run our class methods when the user presses the button. So let's do a quick setup of our app. So we'll change that to the title number shapes, and then give it an ID as well. So number shapes, and increase the size to maybe 30 SP. And I'll just drag that to the middle. Lovely. So number shapes. And then we'll just have a bit of introductory text. So enter a number below to find out if it is a triangular number, square number, or both. We'll just change the ID to intro. And we want that to be a little larger. Try 18. Yeah, that looks fine. And we'll just stretch that out, drag it down a touch. Great, that'll do. Obviously, we're not going for great design at this stage. We just want an app that functions and makes sense. So let's drag in our number text field as before. We can drag it out that way, and we can also just change the width here as we've done before. Great, which is a better way to do it if you're working with different screen sizes, as you probably are. And finally, let's have our button. So we'll change the text there to test number. There we go. And so the ID by default of our edit text is just edit text. I'm going to change it to user's number. There we go. And as usual, our last thing is just to set the on click method here. There we go. And I'll call it test number. Makes sense, so everything's the same. Okay, all right, so back over now to main activity.java, and let's just get the basic logic of our app in, as we're fairly used to doing now. So we're going to create a public method, which is not going to return anything, and is called test number. It's going to be called by the button, which has a type of view. So that's going to send a view variable to our method. Not that we're particularly interested in that, but we have to be prepared to take it. And this requires the view import over here. So android.view.view. Hopefully this is becoming almost second nature to you now, setting up the basic logic for an app. And then all I'm going to do here is get the value of the edit text, the text field that the user has entered their number into, and then put it in the logs. So if you remember, we called the text field user's number. So we're going to create an edit text. I'll call it user's number. And we're going to find view by ID, and we use resources.id.user's number. There we go. And remember, this is a view but we want to convert it to an edit text. So we put edit text in parentheses beforehand. There we go. And now, can you remember how to log using Android? We'll stick with the Android specific log command. So there we go, log.i, and then we'll put user's number in the first field, and then we want to get the user's number for the second field. Let's just put in the import the log framework there, so android.util.log. And then to get the number, we use our user's number variable, which is the edit text itself, and then get text, and then convert it to a string so we can put it in the logs. There we go. So let's just run that and make sure that we've set up everything correctly. Always a good idea to do that before we start doing anything too complicated, just so that we can make sure that the errors are in our complicated code, not in our simple code. Here we go. So again, we'll launch our emulator as usual. And here we go. So let's open up our app. There it is, looking good. So let's just pop 5 in there, test number, and there it is. Fantastic. So everything's fitting together nicely. So back over to our Java file. I hopefully will still have my class code in the clipboard. So I've just pasted it right in there. So there's my number class. Now this time I don't want to have those bits there, but I am going to want them here. Here we go, at least to remind myself how I actually use the class. So I'm going to create a new number, and all I'm going to change here is, instead of setting the number to 49 every time, I'm going to change the number to the value of the edit text field that the user has entered. So we're going to do the same as we did above. So users number dot get text, and we're even going to convert it to a string, but from there we want to convert it to an integer. So you can see actually we've got the error there. If I hover over that, you can see that it's required an integer, which is excellent. That's what we'd expect. So let's give it one. So we saw this a couple of videos ago. We use integer.parseInt. There we go. And then we take our string and we put that into that method. So we're getting the text field, then we're getting the text from that, we're converting that to a string, and then we're converting that to an integer. Excellent. And then that should just print straight away to the logs whether or not it's a square number. So let's test that as it is. And if that works, then we can be pretty sure that our class code has been correctly implemented in our app. And all we need to do is get the user interface working so that it displays something as a toast to the user. Let's take a look. So let's do a square number first of all, 49. True. It's looking good. Try 40, that's not a square number, false. Fantastic. So you can see that was a really smooth integration there, that we just took our class code and copied it straight in and started using it straight away in our app. So all that remains is to check whether the number is square, is triangular, is both, or is neither. That's a little bit of a challenge to work out how to do it with the minimum number of if statements, but as always, there's a fair few ways to do it. I'm going to do it like this. So I'm going to start off to see whether it's a square or not. And remember, because our isSquare method returns a Boolean, I can just put it straight into an if statement, which is really nice. So if the number is a square, I'm then going to have another if statement directly in there. These are known as nested if statements. So I'm now going to check for it being a triangle. And you can see that it's predicting our methods, which is really nice. The methods that we wrote are being incorporated into the IDE itself. So if we get to here, that means that the number that we've got is square and triangular. So let's have a message like we did before that reflects this, and then we can have a single toast command at the end of the if statements. So let's have a string message which is initially blank, and then the message here is that the number, which you'll remember is my number.number, and we're going to say is both triangular and square. And I think a little exclamation mark would be fitting there. And now, before I do the rest of my if statements, I'm going to set up our toast so that we can just check this and make sure everything's working, and then we'll put in the rest of the necessary if statements. So toast.makeText, and then we get the context. The message is message, and as usual we'll use length long, and then we want to show that. There we go. I don't think we need our log message anymore either. So while this is compiling, I'm going to need to think of a number which is both square and triangular. Fortunately, there's a nice easy one. The number 1 is both square and triangular, so I'm going to check that to see if this is displaying as it should. So if I put 1 in, I should get my message. 1 is both triangular and square. Fantastic. Out of interest, what do you think will happen if I put 2 in? At the moment, we get a blank toast because we haven't put in the options for other numbers yet. So, all looking good so far. So let's put an else statement here. So have a quick think, what situation are we at here? We know that it's square because this one told us it was square, but we also know that it's not triangular. So that's what our situation is. So message is my number.number plus, so concatenated with, is square but not triangular. Full stop. I think that's not quite as exciting as being both triangular and square, so I'm just going to have a full stop there. You can choose what you'd like. So that's the first two options. We've got both triangular and square, and we've got square covered. Now I'm going to put an else statement here. So if we're in this chunk of code, that means that the number is not square because this if statement is not true. So the number is definitely not square. So let's just have, in fact, we can just copy that code because our code here is going to be very similar. So if the number is triangular, now here we know that it is triangular but not square. And again, a full stop there. So here it's definitely triangular, but it's not square. And here means it's not triangular and it's not square. So it is neither square nor triangular. And that's it. If I run that, it should give me a correct answer for every number. Let's take a look. Keep your fingers crossed. So we'll try 1, same as last time. Both triangular and square. Great, still working. 2 should be neither Neither triangular nor square. Fantastic. 3 is triangular but not square. There it is. Fantastic. 4 should be square but not triangular. Fantastic. So that's all the different possibilities that we've had there. And let's just check a few more. That should be square but not triangular. There we go. And 28 should be triangular but not square. Brilliant. There's one extra feature I'm going to add here, and that's to avoid this crash that we saw last time, but I set as a challenge for you to fix. I think there's a fairly easy way really to avoid that. There are more technical ways as well, which we'll see later on, but for now we're going to keep it very simple, and we're going to just test at this point. In fact, let's do it slightly earlier. We're going to do a test here to see whether the user has entered anything. And that will work because we chose the number type. Remember when we added the text field, we chose the number type, which doesn't allow even decimals. It doesn't allow anything which isn't a digit. So if the user enters anything here, they can only enter a number. So all we have to do is check to make sure that the user has entered something. So we can create an if statement here, and we can get the value of what they've entered. So user's number.getText, and then we'll convert it to a string. Now we need a way to test whether this is empty or not, so whether it's an empty string. That's not something we've officially seen before, so let's jump over to Google and find out. So Java test if string is empty. There we go. That looks like what we want to know. Let's find an answer. Here we go. Now we know that the string is not going to be null because we're getting the string from the edit text. So there's definitely going to be a string there. It's not going to be non-existent, but the string could be empty. So that's what we want. We want to test the isEmpty method. There we go. So back to Android Studio and pop isEmpty in there. So if it's empty, then all we need to do is set the message equal to please enter a number. And if it's not, then we can do everything else in the usual way. There we go. You can see it's done a really nice job of indenting things for me, and it's also alerting me to a problem, which hopefully you can see what it is. The problem is we've defined the message down there and then used it up here, so I just need to move the definition to the top. There we go. So now we've got a nice test to see if the string is empty, if they've entered nothing, and if so, we give them a relevant message. Otherwise, we process their number. So let's take a look. Probably worth mentioning at this point that there are more advanced ways of doing this test, and you can essentially do the parse int and test whether that's been successful. And that's a better method really than doing what we're doing here, because this relies on the user only being able to enter an integer, and there may be some other options that we haven't thought of here. So really the best thing to do is check that, but we'll see how to do that later on. If you want to jump ahead a bit there, then Google the Java try command. That's the way to test whether a function or a method has been successful or not. But this should do for now. Let's just have a look. So now if we enter nothing, we get a nice friendly message rather than an app crash, which isn't great. And just one more quick check, just make sure everything's still working. 49 is square, but not triangular. Fantastic. So I hope you managed to do at least a good portion of that yourself. It's quite a step up from what we were doing just a few videos ago, really. We're creating our own class with a variable within it and then two methods, which we then use quite neatly down here to tell whether our number is triangular, square, neither, or both. So I hope that was fun. I hope you're enjoying yourself so far. You'll be pleased to hear that we're going to be in Android Studio for pretty much the rest of the course. And in the next chapter, we'll be seeing how to work with images, animation, and sound. I'll see you there.